Good evening, everyone. My name's Daniel Ortiz. I'm the ACR RFS Vice Chair. I just wanted to welcome everyone and thank everyone for calling in on this first edition of the RFS AI Journal Club. I just wanted to give a quick introduction of Dr. Judy Gichoya. She's a senior resident at Indiana University. In radiology. Prior to that, she did a Master's of Science in Health Informatics and has been a prolific informatics expert and coder. She's received several awards. Most recently, at this past RSNA, she received the RADXX Award for a Rising Star in Informatics. We're also fortunate to have Dr. Allen on the call. He is the immediate past president for the ACR, and he is the chief medical officer for the Data Science Institute. With that introduction, we'll go ahead and let Judy take over.
Thanks, Dan. And thank you everyone for joining. This is the first Journal Club, and towards the end, we'll kind of get feedback on how everyone wants this to run. But if you remember, the title of this was supposed to be Radiologists as Knowledge Experts in a World of Artificial Intelligence. And so what I'm going to do for the next 10 or so minutes is to just quickly run through what was, the two TED. So we had two articles, a TED Talk and sort of just an online article to read. And then I'll pass it on to Dr. Allen to give some presentation and what he thinks about AI and the role of the ACR. And I'm hoping that between 8:30 and 9, we'll just have question and answer session and brainstorming of, how to take this forward. But I'm pretty excited to be here. So we had this TED Talk by Jeremy Howard. And Jeremy is a significant guy in deep learning because he runs a free course called Fast AI. And I'll give some links at the end. And so he gave a talk about will artificial intelligence be the last human invention, and also subsequently talked about the future of jobs. And so So he starts by introducing Arthur Samuel, who is considered to be the father of machine learning, and how he trained a computer to play the game of checkers, and in 1962 beat the Connecticut state champion. And so he talks on about Kaggle, and Kaggle is an online forum where machine learning experts and data scientists aggregate. Actually, there are over 200,000 people who come on, share data sets together, attempt to solve solutions and their leaderboards, and talk about data science and machine learning. And so he was the past president of Kaggle. And so he presents his talk as the past, present, and the future. And I'm going to summarize what I took away from this. So he talks about the progress that has been made by social media giants like Google and Facebook, YouTube, and how the self-driving cars, and sort of talks about these processes as part of a little bit of the past. It's what has gotten us to be able to search YouTube pretty fast, classify better search algorithms for Google search. And then he says that one of his passionate things in sort of introducing the present is how this team led by a guy called Jeff Hinton from Canada participated in the Mark data discovery competition, also hosted on Kaggle. And he's impressed because they don't have any biologists or chemists on their team, and in 2 weeks were able to get better algorithms for data discovery. And so in this point, he talks about the present as being that computers can learn, and moves on to describe how computers can listen, because during this live presentation at a conference, this gentleman was speaking in English, and with an automatic deep learning trained machine that was translating into Chinese. And one other thing, so computers can learn, computers can listen, and computers can see. And so Google, I think, used deep learning to for street mapping, and it took them 2 hours just by looking at the images for Paris. And so he talks about this competition again, where the German traffic science recognition benchmark was also disrupted by just people who are using machine learning and deep learning to do this. And so he, he talks about the history of deep learning, and these concepts, I'll kind of summarize them a little bit at the end of my presentation. And in 2012, this was sort of like the first use of deep learning, and this is one of the most common examples that you'll find when you look at deep learning, because it's the ImageNet classifier, which like just is what's in this image. And this data set over 1 million images has been very well validated. There are numerous competitions on this, and previously, before the use of deep learning, which is relies on neural networks and teaching computers how to learn, the error rate was, over 30% and has been declining steadily due to the new sort of better applications of deep learning techniques. And so, on the current, uses, as I mentioned, the case for France, and he demonstrates a case where he uploads a picture of a dog on Baidu, which is the Chinese Google search, and it just searches by image. And the idea of sentiment analysis, like to analyze the mood, whether it's during elections and Twitter comments or movie analysis, and figure out that, a user, this is a negative sentiment towards maybe a movie review. And then how, computers now are starting to read native Chinese, better than human beings. And he actually demonstrates an example where he's showing when you search for birds on water, even if the computer has never known what birds on water could look like, it knows what water is and birds are, and combines the two. And so he moves on to talk about 2 use cases, specifically in pathology and radiology. And if you've been watching at least the press, you'll see how everyone now boasts that they can do better than radiologists, whether it's the Stanford group that said that they could diagnose pneumonia better than 4 expert radiologists or pathologists. And so the next emphasis, like this neural network, he mentions that the computer will, initially the computer relied on the human being to help it train, but, ends up learning new features and automatically, gets better and is able to identify, like in this pathology case, it describes that the computer learned that it's not only the bad cells that should be concerning, but also the surrounding areas. And it says that pathologists didn't know that before. And so he puts a pipeline for, for data and how the doctors would interact with machine learning and data science. And it's mainly in this sort of middle area where, the machine learning will provide, can analyze bigger data sets and optimize recommendations. And then the doctor can, move on and make a recommendation. And so, I find his example of explaining how, how computers learn pretty interesting. He starts with this big mashup of, cars. And so, he just shows that the human being will select a few cars from this data set and says, this is the front, this is the back, and then we'll say, this is a rim, or, this is the side. And the computer keeps learning those features and then ultimately fades out the pictures that are not of cars. But what I thought was most interesting from his presentation was this idea of like the occupation, but looking at, the blue area where he calls this a service, service providers. And, and service providers are either concerned with reading and writing or speaking and listening, looking at things, integrating knowledge. And, honestly, this is what, whether you agree with it or not, is what radiologists are considered to do, We're reading studies, we're dictating studies, we're looking at images and integrating the clinical knowledge. And he postulates that the future will, because of the machine learning revolution, it's on such a steep curve, beyond like industrial revolution, once things were discovered, when things plateaued, that the future of work is a threat, and even especially for service industries. And so he says that what does not help is better education or giving, like more pay. But you have to think about separating, labor from earnings. And if you've been sort of watching the tech world, they talk about, this idea of basic living wage, and just sort of that reskilling is just not enough. And so there have been many of such comments online, where medical students and radiology residents will post. I've seen maybe 5 of these. Are we going to get replaced, and should I change my job? And so I thought that this would be good to think about, like the role of the resident and fellow section in terms of embracing AI, and where do we learn about AI? Should we have communities of practice? Should we have a Kaggle for radiologists, and how would this look like? And what is your present right now in the future of that we see are good use cases for AI in radiology, and what's the opportunity just beyond the threat? And here are some links, and I'll post this online that you can sort of explore more to look at. Dr. Allen?
Hey, Judy.
Well, hi, good evening, everybody. I'm Biv Allen, and I'm the Chief Medical Officer of the ACR's Data Science Center, and it's a real privilege for me to have the opportunity to present to you. And so now I hope that everybody can see my screen, and as I advance the slides, if it doesn't work like it's supposed to, please please let me know. So I wanted to just share with you a little bit about what your specialty society is doing to embrace this new technology. I'm a little bit older. I had to learn MRI in practice, not residency. And I've watched all of the advances that have happened in response to increases in computer horsepower for CT, for MR, the whole PACS and all these things. But I really believe that artificial intelligence is going to be phenomenal in its ability to help us take better care of our patients. So the college, a number of years ago, created our Imaging 3.0 initiative, which was basically the idea of trying to change our culture in response to health reform in the United States from a culture of volume to value. It had to do with putting our patients more in the center of what we do. And in order to accomplish those missions, it revolved around a series of informatics tools that would help us do that. And so AI potentially is just the next one in that litany of things. So if you look at the entire value chain from when a patient is considered for imaging all the way through to the fact they have their result, it goes back to their referring physician and their patient, and you look at what we were able to do in the 1990s with all the advances in modalities from CT and MR, reporting software, electronic health records. For Imaging 3.0, we initially focused on a couple of areas. One is the decision to do an imaging study, and that was the ACR's appropriateness criteria, which has been now in the recently been created into an IT tool called ACR Select, which is embedded in the electronic health record order entry programs. And I think everybody kind of knows about that. ACR Assist is now clinical decision support for radiologists. And it's really integrated into about 75% of radiologists' desktops. And it lets us access, during the time that we're dictating, things that help us classify diseases. For instance, adrenal mass evaluation. These incidental findings white papers are out there. We have them, had them posted on all of our bulletin boards and all that stuff, so we could see these recommendations. But then, if you take these, create excuse me, XML language around it, and you can create this type of algorithm where we can put in measurements and Hounsfield units and stuff and integrate that into the report as we're going on. So in the detection range, still up to humans, but this is where over the next 5 years or so, I think that AI is going to help us not only there, but really across every one of these areas. And so I think it's a great and exciting time for radiologists, and you know, every day I wish I were starting over again. So when we look at this portfolio of IT tools for decision support for our referring physicians, decision support for radiologists, and then artificial intelligence, it's really going to be our next frontier for increasing the value that we provide for our patients. Again, we talked a little bit about the imaging value chain. If you look at this slide, it just goes right from appropriateness determining, patient scheduling, all the way through acquiring the exam, interpreting the exam. And artificial intelligence is poised to play a role at every place in that imaging value chain. Now, I'll have to tell you, everybody is talking about AI, the power of AI, and will it put radiologists out of a job? Some fairly important people have talked about this. Here's Zeke Emanuel, who spoke at the ACR meeting in 2016, I guess it was, talking about how AI was going to replace radiologists. President Obama in this article talked about AI right up for radiology, right up there with driverless cars and Uber. Talk about radiologists losing jobs to AI. So it's really caused a little bit of trepidation in our specialty. And then this was probably the one that takes the cake. This is Jeff Hinton, who a lot of people talk about being the father of deep learning. If you work as a radiologist, you're like the coyote who's already over the edge of the cliff but hasn't looked down yet. People should stop training radiologists now, and so on and so on. He goes on to say, you know, I said this at the hospital and it didn't. He's sort of lightened that the role of radiologists will evolve from doing perceptual things that could probably be done by highly trained pigeons to doing far more cognitive things. Now, a little more thoughtfully is Sebastian Thrun, who says the cognitive revolution will allow computers to amplify the capacity of the human mind, just as machines made human muscles 1,000 times stronger. Machines will make the human brain 1,000 times more powerful. And I think that that's one of the ways that we as a specialty should look at AI. Now, let's compare driving a car to being a physician. Now, I'm from Alabama, and so we start driving cars when we're about 5 years old. But truly, we teach teenagers to drive cars in a few weeks, give them a license when they're 16. Yet you've seen how hard it's been to teach a computer to drive a car, endless numbers of use cases. Now let's amplify that to what we have to do as humans, to go to college and then to medical school and then to residency. So there's a lot for the computers to catch up on. And these complexities are going to confound AI developers. And they will need our guidance from the imaging community so they won't have so many false starts. I think one of the things that my friend Keith Dreyer, who is the chief science officer of the DSI, says that he's worried that if we don't provide a pathway for AI developers to do the things that can help radiologists take better care of our patients, they're going to go do something else, and we're going to miss this opportunity. So we need our collective expertise to find that sweet spot between what our clinical challenges are and what are the problems that are solvable by AI. Back in the 1960s, NASA says that a human is the lowest cost all-purpose computing system, which can be mass produced. So that was pretty interesting. But simulating the human brain, 1 trillion synapses, is still well beyond our computing capacity. And here's just one example. You saw in the videos about playing checkers and how we have a good dog and cat recognizer in this. Chief Mike Tilkin is the CIO, the Chief Information Officer of the DSI, and I want you to meet Rue. Rue is the Tilkin's dog. And when you put, sorry guys. So anyway, the next part of the story is there's Rue, the Tilkin's dog, recognized well by the AI. But the rest of this picture was that Rue had torn up the family sofa in the den. Now a human would quickly put 2 and 2 together, but none of the computers that saw that picture knew exactly what to do with it. So I think it's these concepts that humans can do that machines won't be able to do. Now, as we go and we try to understand what a machine would have to do all we as radiologists do, I learned diagnosis with lists from this book called Gamuts in Radiology. And the gamuts, about 4,600 findings, 13,000 diagnoses, and 57,000 relationships. And when you put that to trying to develop use cases for radiology, you have all of our specialties here on the left, across the top all of our different modalities, and then the various anatomic areas. And so in each of these areas we have a series of findings, and so you start to see what this grid looks like. So let's say we wanted to do musculoskeletal MRI of the knee, posterior cruciate ligament tear. So we teach it to do that, but we still have this whole spectrum of things that we have to be able to teach it to recognize. So thousands and thousands and thousands of potential use cases. Which one of these are going to be important? Which one of these should we do first? Which one of these are really going to make the difference in the care that we provide our patients? And this is a lot about what the Data Science Institute is about. It's how can we make AI an indispensable tool for radiologists? So in the next few minutes, I want to sort of tell you what the college's approach was and then what we're up to. So these are basically the 4 big tenets of the DSI. Ensure the value of radiologists as AI evolves through the development of appropriate use cases and workflow integration. One of the things that we as physicians, I think, must do is exercise our role in protecting patients through leadership roles in the regulatory process with the government agency and through the validation of AI algorithms. We got to know if they work. We got to be able to see that they work and test that they work. In order to accomplish these things, we need to establish relationships with industry developers, provide them credible use cases that will get their products to market, and then help with the FDA and other government agencies so that they have pathways to clinically integrate their tools. And then finally, educate radiologists and other physician stakeholders about AI and what our role in data science is going to be. So when you look at all of the different things that we as physicians need to understand and opine on and be outspoken on behalf of our patients, I mean, you can see this whole list of things. Our initial focus really is going to be toward use cases, defining those cases that intersect high value and with the problem solvable by AI. And then within these use cases, build the data elements for the use cases to create annotated data sets that can be used for training, ensure patient safety, and that these use cases will have data elements for validation, sort of in the pre-FDA approval process. Ensure that the use cases have data elements that allow effective clinical integration. and then creating validation sets to test and train these and monitor them in the wild. So these are all the data elements of our use cases. One of the things that I think is important, these guys, as you see, are very, very smart. The computing power is terrific. But they sometimes don't exactly know what to do. So you talked about Kaggle. Kaggle put on a competition, gave $1 million prize around lung cancer. And the guys that won could say that this nodule has an 85% chance of being cancer, and this nodule has a 15% chance of being cancer. And that sounds great, all well and good, but really as physicians, we know that we're going to treat those patients the same. So why didn't somebody tell them, well, what we really need to do is for you to do this and populate our lung RADS criteria so we can pre-populate this in our reports and see the criteria. What we really need to know is to be able to measure the volume of these nodules on follow-up scans so we'll know what's happening to that nodule real time. And so the ability to physicians to work with the developers to cull out these high-value use cases with the problems that are solvable by AI. And I encourage everybody to go to the ACR's DSI website, acrdsi.org, to take a look at this. So in the last 5 minutes or so, I want to go quickly through a use case. So this is a pediatric use case panel. We call this process with all of these data elements, technology-oriented use cases for healthcare AI, or we're going to call that Touch AI. And we look at intraventricular hemorrhage in neonates. And we all know about this. It goes from normal to germinal matrix hemorrhage all the way through hydrocephalus and periventricular hemorrhage. Teach it normal anatomy, as well as the classification scheme. Whoops, sorry, get to right there. So now then, you have to, and each one of these is an individual use case. So is there germinal matrix hemorrhage? Is there intraventricular hemorrhage? Is there hydrocephalus? Is there periventricular hemorrhage? And that will give us the grade. So as this is done, these are kind of fills in the blank algorithmically, and this computes and can grade the hemorrhage. And that's kind of how a use case works. We've done some proof of concepts. We did one for around pediatric bone age to make sure we could build all these elements into it, and Nuance used this framework in a demonstration they did at RSNA this year. So in closing, we'll go through this sort of ideas to using clinical data to build algorithms, to build clinical products in clinical use to meet the needs of physicians and our patients. And all of this is going to be derived around the AI use case. But there's some challenges. We need to bring these great ideas together with the clinical needs. We need standardized methods for annotating, aggregating data, and training. We need standard methods for AI model validation. And we need a mechanism to integrate and model and monitor these AI models in clinical practice, giving us feedback from real world experience. So again, we talked about Touch AI with our data elements for the concept with narratives and flowcharts, data elements for annotation and training and testing, data elements for validation and statistical metrics, so we can compare apples to apples with these algorithms. To integrate the data elements for clinical integration, whether it's in our reporting software or on the console, and then data elements for how we'll monitor these in clinical practice. We've got use case panels now, similar to how the ACR did the appropriateness criteria panels, to develop and evaluate use cases for artificial intelligence. We talked a little bit about using these tools for AI authoring. For AI certification, we envision that developers can partner with the college, who will then partner with institutions to do validation that would end up creating a report that could be used for the FDA to head off and help them with their pre-approval process. Now, we talked about ACR Assist before, and so I'll show you sort of how that works. Now, the classic ACR Assist, where the radiologist puts in the data elements that would generate a radiology report around lung nodules. As AI develops, maybe AI will be able to populate some of these fields by measuring the nodule, detecting the nodule. And at some point, AI may be able to actually pre-populate reports for lung rats. And that would be a good thing. Again, helping us with something that we need. And then finally, monitoring AI in the wild, using registries to gather feedback to see how the algorithm is working. You can imagine somebody had a stroke detection algorithm. It worked perfectly everywhere, except when they got it in the field, they had a few places where it wasn't working. And with this registry data, we can learn that it was, it was Philips 3 Tesla scanners, and that information could be used to report back to the FDA and for the developer to remodel their algorithm. So we think that these two things, that this pre-market review and certification and this post-market surveillance, are going to be ways that the college can help developers and the FDA getting these to market. The FDA process now is to try to shift from pre-market review to getting products to market with an emphasis now on real-world experience and post-market surveillance. So William Gibson says the future is already here, just not evenly distributed. But really, it's not humans versus AI. It's going to be humans with AI versus humans without AI. And I think we know the answer to that. I think none of us are ready to fly on an airplane without a pilot. But on the other hand, none of us want to sacrifice all the safety features that are built into the autopilot. And this will be the same with AI. So we'll provide greater detection, better treatment, and ability to optimize patient care. So just in closing, AI is poised to enhance all aspects of radiology. It will help us with our decision making and greatly improve the care we provide our patient. Radiologists have the opportunity now to become medicine's data scientists. And with that, some discussion. And I'm going to just kind of throw up some questions here. When will this happen? Will it replace radiologists? What should I do if AI is looking to purchase AI tools? Is it the same as CAD? And so what's going to be the killer app? And so with that, thank you very much, and I'll turn it back over to the moderators.
Thank you so much, Dr. Allen, for a wonderful presentation. And folks, we're still on time, and I have to apologize that my slides did not show, but it really was a summary of the TED Talk. So we can go ahead and have some questions. You can raise your hand in the GoToWebinar app, or just type your question and I'll read through it. I think Ivan asks Dr. Allen, will the slides that Bib is showing be shared?
Oh, absolutely. The ACR Data Science Institute will have lots and lots of slides and educational material. This was really a culled down version of a number of different things we've done, presentations that we did at RSNA, things that we did that we've developed sort of for a kind of the road show of about an hour-long slide set that some of these came from. So absolutely, these will all be available.
Okay, thank you. Ivan says, Dr. Allen has said radiologists have the opportunity to become medicine's data scientists. Can you please elaborate on this? What should they start doing to move in this direction?
Well, I think that One of the things, so when I was the board chair, I had the privilege of talking to the Institute of Medicine about improving diagnosis in healthcare. And we talked about imaging 3.0, and we talked about going from volume to value. We talked about appropriate care. We talked about standardization of care to make sure that for the same thing, all of our reports basically say the same thing and make the same recommendations. And the IOM, or the Institute of Medicine, concluded in that report that managing information is probably the biggest key to preventing diagnostic error. And it's my belief that we as radiologists, for patients that are ill, kind of hold the keys to most of the information that's happening at the hospital, and that we will be able to be the ones that will integrate material from the electronic health record, from pathology reports, from genomics, from other places, and bring that to bear. So I think that, yes, managers of information, again, we will be in the role of being medicine's data scientists.
Thank you. Akshay asks, when one radiologist can read at the speed of 3 radiologists because the accuracy is high and measurement burden is low, won't the demand for radiologists go down?
So what I believe, and I think number one, let's fast forward this to decades, because I think, as you saw from that slide, about being able to teach a computer to recognize every potential diagnosis on every exam and then reliably exclude that exam is not there. I don't think that we should see this as a computer interpreting the examination. I feel certain that in the near term, again, years, that the FDA and others will want to assure that physicians are in between the answers that the computers provide. But if a computer is able to help us reach a conclusion quicker, particularly on cases that are somewhat simple, it allows us then to bring to bear information about other patients that are more complex. So I see our role potentially changing a little bit. Imagine that right now, we focus decision support for our referring physician on exams that they shouldn't order. Well, what if AI is able to tell us exams that they should order? What if we are able, with genomic data, to understand who needs a CT scan of their abdomen because their risk of pancreatic cancer is high, and others? So I think that we'll go from one to another. A little personal note, probably 15 years or so at my hospital, I was doing about 8 cerebral arteriograms, catheter cerebral arteriograms a day. And if somebody had told me 15 years from now, or even, because it happened faster than that, even 5 years from now, you won't do any. I mean, I haven't done a catheter cerebral arteriogram in years. And I mean, our practice is different. It's not that it's not that we need less radiologists because we're doing less cerebral arteriograms. So I think that this is what AI is going to do. I think as one part gets easier, there's going to be so much more information to manage that we'll be changing the way we practice, and I think we'll be changing it for the good.
Okay. So Patricia notes that makes a comment that it's not reading at the speed of 3 radiologists, but reading at the accuracy of 3 radiologists combined. That could represent the future. Now we have many questions, so I'm just going down the list. Anthony Chang says, I think radiologists who refuse to learn about data science will be less relevant. It's similar to cardiologists who refuse to be trained in radiofrequency ablation in the 80s. You can survive, but you'll just be less relevant. And so Dr. Scott Steinberg, will radiologists who fail to learn programming and AI basics become the radiologists of the 1990s who failed to learn how to read CT and MRI?
Well, Judy, I may let you ask that question because you are, you're already our data scientist and you're a physician. So where do you see the intersection? How much programming do you think radiologists should know, or do you think that physicians should leverage their knowledge with data engineers, statisticians, mathematicians to have a team effort to meet the clinical needs of our patients? Maybe I tipped my hand a little bit, but I think that you're in a great place to talk about that.
Well, I'm going to answer Dr. Steinberg. I think just given our clinical duties, it's very hard to become great programmers. But as someone who's currently going back and learning through deep learning, truly the code that's needed is very minimal. But the big concept is the challenge of understanding what the algorithms are, what the people are doing with the data. I feel like that even most courses do not explain that very well. But I feel like at least any radiologist should understand that you don't need to program, but if I come and tell you that my algorithm is the best, you need to be able to understand, like how can I evaluate it, or be in a network where you can sort of lean back maybe to the ACR and evaluate it. But I do think some basic understanding, which is actually the format of the Fast AI course by Jeremy takes, where you're looking at top level and peeling down the masks for the learning methodologies, will be really beneficial for radiologists. And Monica Wood asks Dr. Allen, how will the ACR DSI help ensure that the AI algorithms trained at one institution will work across other protocols and hospitals?
If I understand the question correctly, so one of the things that creating these standardized use cases is it allows developers to create algorithms that all look the same, or I'm sorry, that are doing the same purpose. To go back to the last question, I think one of the things that developers don't always understand is that, they may understand who the human actors are in the software development process, but they don't always understand how the humans interact with our electronic resources. So where is the input coming from, the information that is coming from to the algorithm, and where is the algorithm going to output its answer so that it'll be workflow integrated? For instance, if somebody built a fracture detector algorithm, and so I could look at this ankle film and it would tell me whether there was a fracture or not. If I had to get up from my workstation and walk across the room to check the AI server, we would never do it because, we as radiologists are pretty good at recognizing when there's not a fracture. So I think that the developers and the physicians together will have a good partnership in that. And I think that developing use cases, and just to go into this validation process a little bit deeper. So the use case would have the statistical metrics of how to test it. Now, I'm not going to get into what would how we would calculate an area under the curve versus the dice coefficient or other things that people are using to validate the algorithm. But on the other hand, if you're going to do that, you need to be able to do it uniformly. And from institution to institution, it would be like, to me, a little bit like a clinical trial where, where a developer would have this and the ACR DSI would know that, okay, Johns Hopkins has a validation set around this, the University of Chicago has a validation set around this, UCSF has a validation, and we would put the developers in those institutions, and then they would be able to create, it would have some geographic diversity, institutional diversity, potentially scanner diversity, slice thickness diversity, all the different parameters to make sure the algorithm, doesn't break just because it's not a GE-CT scanner. Okay. Was that close to answering the question?
Our attendees will have to react to the answer online so that I don't Yeah, Monica would agree and says thank you for your answer.
Okay.
So Leonard, Eduardo, and Anthony sort of ask a similar question, and this is about, do we think there's a need for a residency in healthcare AI? Or Eduardo from UCI asks, should we include AI basic training into medical education, radiology curriculum, or CME? And Anthony Chang asks, maybe there should be a future specialty of the medical image specialist to also cover pathology? And so maybe you can make a mention of the training.
I think that's great. I think you're exactly right. Those questions have a lot of similar pathways. I'm not sure that AI in medicine is going to be, a residency as such, because again, AI is going to be sort of use case per use case. So there will probably be some AI applications that will happen in orthopedic surgery that won't be useful in radiology and vice versa. However, I do think that there are great opportunities for collaboration among specialties around AI use cases and bringing healthcare teams together based around clinical problems that are common to those specialties. So in that vein, yes, I see close collaboration with pathology in particular regards that. I'm hoping that, I think we as radiologists, this is probably on our radar ahead of everybody else in medicine. So I'm hoping that some of the things that we're doing in the Data Science Institute, if they tend to work, will be adopted by others so that AI development won't be really the Wild West and there'll be some standards. Remember, well, maybe you guys won't remember, but I remember when PACS first started out, there was no real standard for the data format, and DICOM came after the fact. And so if we can have some standardization ahead of the game, I think will be helpful. Now, regarding radiology, educating radiology residents, the college has played a big role so far in creating modules for teaching some of the non-interpretive skills, for instance, around leadership and professionalism and around economics and health policy. Excuse me. And and we are now in the process within the DSI of looking at creating modules for residency programs that will be primers in AI and AI in healthcare and AI in radiology. So I think that will hopefully be what radiology residents need. Now, there will be plenty of people probably interested in doing fellowships in informatics as well.
Okay. And so I'm going to try and summarize so that we answer the question, most of the questions. As Sam asks, I'm reminded of the early days of PACS, where we let the development get away from us and the vendors created products that appeal to IT and C-suite types that were not optimally designed for radiologists. How do we get involved in AI so this doesn't happen again? And this question is repeated by Brian, who asks, as residents, how can they get involved? And Anderson, who asks, as a medical student going into radiology, how do you prepare yourself to use this technology rather than limit you?
Yeah, I mean that's great. I think, and one of the things that we're going to be doing, I would think within the first quarter next year, is having some educational information. So as a radiologist, how do I get involved? What do I do if IBM comes and says, we want you to help us with AI? And hopefully the answer to that will be, look to the professional organizations to say, so what are the use cases? So you want me to annotate data sets for you? Good, let's do it around these use cases that are being developed by the ACR committees, because we know that these are going to be the ones that have been looked at, are going to be valuable to patients. They'll have the stamp of a professional association on them. And so to try to work with developers and steer them in the direction of leveraging, your skills, your understanding of what our patients need, and not just sort of doing exactly what they ask. I think that's a great opportunity for radiologists to provide a leadership role at the grassroots level.
Mm-hmm. So I think there's a question that we haven't answered. How will smaller groups or private practices be included in the ACR effort in AI development? And maybe when you're answering that, you can expand on the regulation of AI algorithms and how the FDA and ACR will ensure clinically robust algorithms.
Okay. Well, I think that, again, this model that we're proposing, having a use case with data elements that indicate exactly how images should be annotated to provide training sets for developers, is something that, you don't have to be at MGH to be able to do that. You can do that in community practices. I have some friends who are in community practices who've already been approached by certain developers, Google or IBM, who've asked them to annotate images. Now, again, that's a little bit of, ahead of the, that's why this is happening so fast. But I think that, so on that front end, I don't think that you have to buy a bunch of NVIDIA GPUs and write algorithms to be involved in AI. I think that radiologists can be involved in annotating images for training and working with developers on the training and testing side. Some groups may even want to do the validation sets. This will be a little bit tougher because there has to be, a little more robust ground truth, maybe more than one radiologist deciding that this was the particular answer. But on the other hand, I don't see any difference between private practice and academic practice in that regard.
Okay. And so I'd like to spend the next 8 minutes of this call to get feedback from the attendees on, what do you think this journal club should take, the form that this journal club should take? Do you prefer if we review like actual like AI deep learning articles, let's say like a bone age use case, or would you prefer to have speakers come on and make a short presentation and we can ask them questions? Or, other suggestions that have been there have been, could this group join together and take, like an AI class together, asynchronous, but just be sort of connected to each other? And I would like to see some comments in the sort of like the answered questions to see what everyone is thinking, or just unmute yourself and say it loudly. Okay. As I get those, some responses in. Anderson, I see your response, like he likes the idea of the class. Several people seem to like the idea of an AI class. I'm going to summarize what's been my approach. And I know some people online, I don't know if Alex is on, there have been some radiologists who have attempted to sort of learn, especially the idea of deep learning on their own. So my strategy was I paid for a Udacity class. And I'll summarize these notes later and email them to everyone. And the problem with that class, I can program. If you can write Python code, you can understand anything to do with sort of like the basic code. But the problem was there was no like explanation of the big concepts. It was more of like, trying to debug a Python algorithm, which can tend to be a little exhausting if you've had a long day at work. And so I didn't feel like I was making a lot of progress, despite that the Udacity course has lots of, machine learning experts. I think one of the best classes I've liked was the Fast AI course, which is actually ongoing. It goes on every Monday evening. It's live streamed on YouTube. It's free, and the course takes one concept and explains the broad concepts, so you can understand things like convolutional networks, transfer learning, natural language processing, how to train an algorithm, how to deal with structured data. So even if you're not so much into programming, I think you start to see familiar concepts. And this course also does not take an approach of homeworks. All you have to do is participate in more Kaggle competitions and just keep improving yourself. Other people are commenting, like Eduardo, he's been using Udemy, which is also something that's available online. And so I'm just going to, Lynn, there's a really good 10-week free course online that is good intro to machine learning. It would be great if you could post the link in the question window, and then I can link it to everyone. And so Justin notes that we could have an alternating journal club between TED Talk, blog speaker, and a use case. Several reiterations that they like the workshop idea. And then Akshay would like to see speakers from AI industries to speak about their perspective would be very interesting. Actually, so once a month it should be a class, other ways to apply AI cases. And so would people be interested in like a quick sort of like Shark Tank, where people can talk about what they're working on in AI and people can critique the project or something like that? Would that be something of interest? And feel free to like email some of the responses after the journal club. Okay. So Brian would like to see more collaboration opportunities. Well, we have 4 more minutes, and I'm going to maybe ask Dr. Allen what, the last question from Ian Weissman, what strategies should radiologists use to remain relevant as AI improves? And then I'm gonna keep watching out for your responses and summarize them at the end.
Well, I mean, you're right. I mean, I think the key is for radiologists to remain relevant. And I think if we are under a rug and just ignore AI and believe it won't ever affect us, we're going to get left behind. And I think somebody mentioned it. I think the very first comment that we heard from one of the participants was just that. He said, if you don't embrace it, if you don't understand it, if you don't use it to help improve your practice. So I think that what radiologists should be doing, even those that aren't participating in the development process or doing anything with training or participating on a use case panel, or but I think all of us will be benefited if we keep up with how industry is delivering these products to market. To follow our transcription software, see what M-Modal has, see what Nuance has regarding what are they integrating into their systems that are using AI. And when that comes around, look for the things that will help you improve your value as a radiologist, and use that information to take to your hospital administrators and say, look, this is why we need these tools in our practice, because it's not just for me, but it's going to make us as our team in radiology so much more relevant to the hospital, to our referring physicians, and most importantly, our patients. And so I think if you just sort of sit around and wait for, the ER guys to buy a not broke fracture detector, kind of thing, and then say, well, radiologists don't need to read any of these films anymore, you're going to be behind. I think we need to own that technology so it improves our practice and that we leverage it to be able to improve the care we provide our patients.
Okay. Tarek, I see your hand up. I don't know if you want to ask a question. Tarek or Eduardo? If you... Tarek, you have a question or a comment? Okay. So, well, it's 9 p.m. Thank you everyone for attending this first journal club. I'm going to summarize the notes in a blog post and share it with everyone. We had set up a survey just to get to know who's interested and what how can we make the journal club better? If you have a moment, please answer. It just takes less than 5 minutes to, complete. And please feel free. I'm going to put my email at the chat. Just email me and just give me feedback on how to get this journal club a little better. And look forward to seeing you next month. I'm going to hang around for a while so that if anyone has questions or anything, they can just post and we can just, keep talking. Otherwise, thank you, everyone.
Judy, great work. This is Bibb again, and thank you so much. And as you build this out, obviously, those of us working in the Data Science Institute want to remain engaged. We'll help you find speakers, help you with whatever you need, whatever the college can do to support this effort. It's a phenomenal thing, and thank you for letting me participate tonight.
Thank you. Okay, I don't see any more questions, but people are dropping off. Thanks again, everyone, for attending, and expect an email from me. We're going to close the chat. Thanks again.